So I'll tell you why we put that. I bring this topic because I embarked about 7 years ago. I met 2 students out of University of London, and they came to me and they said, well, we have this algo, AI algo, ML to predict PTRS. I said, oh, okay, cool. And we put a small student sponsorship in place, right? I think that was like $10,000, right? So we give them $10,000 and we say, hey, if you reach some milestones, we give you another 10. So we embarked on that, and we realized we did the algo, we did the model. They were sourcing database that were publicly available. 2 guys, right? 2 data scientists, and they came and they had a good area under the curve and looked good. I mean, and then we start looking at the drivers and everything. So we learned a lot. The first thing we learned is that it's garbage in, garbage out, and I think 2 guys don't, as smart as they are, will never be able to build a very thorough, strong database to feed any algo. The second thing we learned is that the algorithm is not the value. The algorithm is really commoditized. It's a commodity. The value is in the data that you feed the algorithms. And so if you want to achieve good results, you need a really strong team of data scientists and clinicians and science experts to really cure, index, and clean the database and whatever database you do. Okay, here we are. So what I'd like to talk about in this specific presentation is a very humbling experience about how we got to use AI in the context of portfolio management. And it's humbling because I think initially we thought it would do the dishes, and it doesn't. So I still do it at home. So the second thing is that it's very useful, but it's a tool, right? It's not going to give you answers to questions. It's not like the magic ball, right? You shake it and it tells you invest, not invest. Doesn't do that either. It's a tool to help you make decisions, and I would say mostly add rigor to the whole process. So it's really how you need to understand, at least us, that's how we understand it as of today. That's the reason why I think before we embark in any AI adventure, and specifically in the context of portfolio management, we need to understand the DNA. What's the DNA of the organization? And the CMS, so the statistics team, came to me 5 years ago and they said, oh, you know what, we're going to build an AI structure internally, and we're going to do great, and we're going to predict to top management what is going to succeed and fail. And we're a small, mid-sized pharma company. And I said, stop, right? You're not going to build a 70-people organization just to say PTRS is 50 instead of 42, right? Or you cannot do that. You cannot put 2 guys and do it. It's not going to be any good. So understanding the DNA of the organization, I think, is critical. And that's also understanding the strategy, understanding where you want to go, understanding the profile of risk you're ready to take, and all these kind of things before you make any investment in that field. So the next slide, really, should I drive from there? Okay. Yeah. Okay. So that's why if you're a small company, you don't need the same infrastructure as if you're mid-size or if you're large size. And I would say in our case, and everything left of large, I would say don't even try, because you're probably going to get lower quality for a bigger investment than if you buy outside, right? Rent it outside. So that's really that. On the right, these are the key questions we consider in portfolio management, right, before we make a decision. So this is a list, and it's not complete, but it's just an illustration of the type of question we ask ourselves. I wanted to share with you, and these are the questions. And that was funny because we are a privately owned company in Germany, right? There's about 330 Merck family members in Germany. And so I got to ask the question to the chairman of the family board. And I asked him, I said, when I was in banking, I was asked in wealth management, I would ask 3 questions. What is your time horizon? What is your expected return? And what is your tolerance to risk? And so the answer was, time horizon is forever. Your company is 250 years young, right? Merck is 356 years young, and they hope to get it for the next 350 years. The return didn't answer. We know because we have a WACC internally. I cannot disclose it here, but each company has a weighted average cost of capital. So I think that should be about the guidance. And the tolerance of risk, nobody ever answers that one, right? Because if it goes up, everybody loves you. And if it goes down, everybody hates you, And when I was in wealth management, I launched Stock Don't Do That in small mid-cap biotech. And the thing would go up 10% one day, down 10%. Guess which day I would get the call from the wealth managers or the clients? Only the days it goes down. They never call you when it goes up. So it's an asymmetrical risk. That's what I'm talking about. So these are the questions I think are important. I don't want to go through them, but I just put them there because we're sharing right here. It's a show and tell, and it's really for me to share with you how we do it. But now, if I go to where AI is applicable in our process. I apologize for the graph, right? It's overcomplicated, but in post-hoc assets, we go through these different stages. These are the input on the right. And what I try to illustrate here is in green, where we are already applying AI. Yellow is where we would like, we are in the process of applying AI, and red where we don't apply AI, but where I still believe there's opportunities. So I would love to hear if one of these is red on us and it's green on you, let me know, because I would love to learn from your experience. But clearly we've focused on POS and PTRS, as I mentioned, R&D timelines, because this is a low-hanging fruit when you start having the database, and I'll show you its illustrations. These are really the areas. Also, R&D costs, I think that's a good one, where the applicability is good, because sometimes, we see a lot of slippage in timelines and budget. So it would be good to have a sounding board to help us, narrow a little bit the uncertainty around these things, timelines and R&D cost on top of the PTRS. Marketing and sales cost, sales forecast for me is a big driver, right? That I believe if we can crack that one, that would be wonderful. For early pipeline, we've developed a different model. We stole without shame the AstraZeneca 5R. We just added one dimension to make it ours. It's the right feasibility. So don't try to guess which one. I tell you already, it's the pink one. And there we started thinking, because it's semi-quantitative, to see where we could add quantitative methods that pulled out of AI. And this is where, in green, same methodology, right? These are the areas where we already implemented these AI capabilities. And once again, the right commercial, for example, is not an area where we've been able to apply these methodology and these tools, as well as right tissue and molecule. It's still a challenge that we see. We hope that we can get there. So same thing. If you have, solutions to share, we'd love to hear it. And right patient in yellow. And I'll see why the right patient in yellow. We've had an experiment with Quantum Black, which is the AI arm of McKinsey, and they're offering some services in that field that I will share with you, at least the methodology and a little bit of what we saw there. Beyond that, and if you take the ecosystem overall, right, there's a lot of converging services, right, around AI. And that's what I wanted to illustrate here, because, of course, I'm entering from the window of portfolio management, but of course the ecosystem is much wider. And why I show you that it's not so much to show and tell, is because I believe there are bridging opportunities between these different services, because each of them is trying to crack and answer a question. And in order to do that, because as I said before, the algo is not the matter, is the database. And so if you can use the wonderful database that are created through these services, with external data as well as internal data, and you can bridge these data once they're high quality and cross-pollinize the different services with data that are generating different points, you're probably going to have better outcomes with the said services. So that ecosystem needs to communicate, and we need to be able to extract database, pollinize and populate the other services with these databases that are really where the value is. Decision trees. So I love the previous presentation because that was the perfect bridge. So super important. We try to put more AI in it because, as you said, there's so much bias. And I was reading one of the publications from Novartis, right, regarding PTRS and the methodology, the Bayesian, right, the one that was published a few years back. And the first statement was, our baby is always nicer than any other baby in the world, right? We overestimate PTRS. So I think this is where I think AI can help probably remove a little bit of this bias. So that's why I put it in there. And we are in the process of optimizing. So let's get now in show and tell and how we use, I have to disclose because they're in the room. I didn't know when I prepared the presentation yet that Intelligentsia was coming, but we've been working with them. So I'll show you a few slides directly coming out of their because we are subscribed to the service, so we have about 1 year, 10 months experience with Intelligentsia. I've followed them for the past 5 years, but we had a little bit of money left in the budget, so I was able to contract a little bit more than a little, but left on the budget, so we were able to contract with them, and we've been partnering since then. So one of the first things we did is compare our internal data with their data. So that was the first thing. We said, oh, do they know really better? And is it different? So I was sweating, to be honest, when we pulled the data. And we put it on the pain ruler, the one that has no numbers, right? And to see how the range, right, compares. And to our surprise, we're not that off. That the range of PTRS, so the relative value of PTRS among our different projects compared with Intelligentsia data and our own data were very close. So there was the logic, the relative logic was right. The absolute values were off, but because we're overly optimistic. So that was not a surprise. So lesson learned number 1, we're not totally off in a relative value. We off in absolute value. So that was lesson learned number 1, and that's what we were looking at it. The second is, looked at the ranking because we prioritize, we try to prioritize exactly what you presented this morning. We try to do the same thing you do at Novartis, right? This is use to prioritize and to rank the different projects from a strategic standpoint for decision-making, also from an operational standpoint, because that's PTRS is one of the big feed into the ENPV delta if you delay versus if you accelerate. And so we use PTRS as a big driver in the measurement of what should go first and where we lose the most money if we delay. Another finding, because when you pay that kind of service, right, wherever you go, you want to get a return on investment. So I was looking at ways to justify for the investment and to continue the investment going forward. So in collaboration with the team, we looked at what was possible with the database. I said, good quality database, how can we leverage it beyond PTRS? One of the opportunities to look at the future competitive landscapes. It's pretty good at that, actually. So I thought that was a good use of it. So I called my GSI friends, Global Strategic Insight, Competitive Intelligence. I said, hey, you're doing it manually. Would you be interested in having somebody who at least, challenge you a little bit on what you see, have a more complete review, and then give you a little bit more guide, a little bit a sounding board or just generate it for you. So that was one of the output I thought that was a hidden value initially, right? That exists here. The other one is time to market. So as I said, timelines is really an area where we need to make progress. We see timelines slipping all the time, right? Budget and timelines, 2 areas where difficult to be correct the first time. So I think that's another area where I see a lot of value collaborating with, with AI and using AI as a tool as a better predictor of your own timelines or your competitors' timeline. And we saw that, in the previous presentation, timeline is a big ENPV, right, driver. So distribution is an area for me that, I have 3 pillars in decisions in portfolio management, right? Opportunity, risk, uncertainty. I try to improve the opportunity, reduce the risk, reduce the uncertainty. And so uncertainty drivers and reducing uncertainty and understanding it first, and then finding ways to reduce it if it's really significant is a priority here. So I'm not sure yet how to fully leverage this uncertainty and finding the drivers behind it and see how we can influence the drivers. But to me, that's an area of focus as well. So drivers. So I've been talking about drivers, and to me, I was looking for gold and platinum there, and I see intelligentsia people in there, and I keep telling them I found silver so far. Not bad, but not yet. So I'm still digging, and they're digging with me because we partner in crime, right? They want to demonstrate the value, so we're still digging. I think the mistake we made in looking for drivers for gold or platinum is to look at the big drivers. And when you think about it, if you move your PTRS by 0.1%, that's enough to justify for the investment. So I think probably we've not talked about it, but we need to talk about it. But I think we need to start looking, because we looked at the big ones like plus 2%, plus 3%. And most of the time, these are things that they're not actionable. They're set. And probably the gold will be in the lower drivers that we can influence in the design of the study or where we do the study or the population. There's probably gold there, and we try to look at the big ones instead of looking at the smaller ones. So probably that's where we should go. But still looking. I love the drivers anyway, because a few years back we were doing PTRS, and people would say like that, right? From there we did checklist, and okay, we had a checklist of 40 drivers. Here you have 270 drivers, right? So I see the power of AI being able to put together a lot of drivers and identifying the ones that matter, and also the ones that don't matter that much, but you can influence and therefore change a little bit your PTRS. Okay, the other topic, so done with AI and PTRS. Now I'd like to move to indication ideation. That's another area where I think there's an applicability of AI, and we tried it with Quantum Black, so the McKinsey AI arm. And the idea is that, as I put it there, right, the AI in green is the indication ideation at the phase 0 moment. Once you have enough data to start and you have an idea of the type of indication you're going after, it's oncology or it's immunology or it's dermatology. So you have narrowed already your field, and you have pretty much an idea of 1 or 2 or 3 indications that you would like to focus on. And so what AI does is that, and the way they do it with ICD-10 data, patient journey data, very clinical and biological, they're able to take the cloud and see proximity of indications. And so that enables you 2 things. 1, to see what are the more proximal indication, and second, to identify indication you didn't even think about. So you have 2 steps. Of course, you don't leave it there, and that's why I showed this. You need a filter, right? Very quickly, you need to make sure that fits, number 1, your capabilities, number 2, your strategy. And so you have to be very quickly selective about all these indications. And third, you can put AI for option components and selection prioritization, and run big data and things like PTRS on top of it. Because if you have on one end these ideation and it gives you 10 indications, and then you have one that has an 80% chance of success and the other one 20, you can start, based on your strategy, right? we are more risk adverse, so we probably would go with the 80%, even if it's smaller. Another company might say, you know what, I have enough of these low risk projects, I'm going to go for the big one. And that's the one that I put in the bucket of high risk, high reward. And I need a high risk, high reward to balance my portfolio. We're talking about the portfolio balance. So depending on what you try to, and put your filters, and then AI can help you figure out, optimize that. Decision trees, so I put AI there. So here you go. And consistent at least. So this is how Quantum Black does it. So I shared this. It's not proprietary, it's standard, but the methodology, I share it here because they build the patient cohort based on real world data. They build the embedding of clinical events, so the patient journey, right? What happened in this disease, and then select referential and rank indications. So you build this multi-dimensional. So here it's a 2D, right? You see the cloud at the bottom. Of course, it's more than 2D, right? But it, for a slide, I can do only 2D, and you see the proximity, right? So the proximity score is a multi-dimensional proximity score. So you have to imagine it in more than 3D. It's a 50D or a 60D proximity score. And then you prioritize your indications, right? As I said, with other filters, other methodologies, we have something we call Compass, which is our own methodology internally. Each of you, I'm sure, has their own filters. So with it, that's about my time to conclude. I think it's just a show and tell. It's just very humbling, as you can see. It's a few indications, few stones we turn that we think still carry some value. And I wanted to share with you, but I'm really interested to hear what you have to say about your own experience, and also how you believe AI can help you in better managing the pipeline and the opportunity, increase the opportunity, reduce the risk, and reduce the uncertainty. So with that, thank you. A few tips and tricks that I'm not going to go through. You'll have them on the web. But thank you for the opportunity and the time.
Questions?
Thanks. Great presentation. Love trees too. Global warming. In your aggregate, right, when you took the RPTS factors, you're down to 270 factors, but you're looking at smaller percentages of changes. So what you're doing is taking a large percentage change and disaggregating it to lots of little factors that are actually correlated, or are those truly independent factors that you have to take into account? I just can't imagine.
So they're all independent factors. So, maybe I could ask Intelligentsia to answer the question, but because I've been disappointed with the big ones, there were individual factors that were perfectly identified. So I think we need to go more granular and go deeper to understand, but they are de-aggregated.
Ivan, I was wondering if you could expand on your experience with the indication proximity, because right now, a lot of the real world data and the ability to follow patient longitudinally is very weak. Mm-hmm. And also a lot of that data centers on very US centric.
Yes.
So how are you accounting for some of the pitfalls here?
As I said, it's an experiment. We've done it. So I'm going to answer into, first of all, yes, it's US data. As I said, ICD-10 is US as can be. So it's very US-centric. The second thing is limited, right? As I said at the beginning, right? The ecosystem we are building today, we have to leverage it to be able to be more complete with. So for example, with Quantum Black, we are talking about, chemical structure, this optimizations. So what AIDD does, right? If it would be possible to pollinize their ICD-10 with more research data that make it stronger in terms of predictive value, as well as a follow-up to have longer term data. This is what we have. So we play with what we have today. but there's a lot of opportunity to improve the quality, the area under the curve, or the value of these systems. I'm absolutely convinced that we're just exploring the first. We pay big bucks for that, by the way, but it's McKinsey doesn't come cheap, but it's we wouldn't know. But we are for me, it's experimentation at this point. I think as long as you can afford it, I think there's value already, but it's just that we're still toying with how to improve exactly the direction you said, right? It's can we make it global? Can we improve the predictive value? Can we improve the area under the curve and the applicability of it? Can we expand it? So, for example, I'm going to go in more details. We did monospecific, right, with quantum black, easy, with the limitation you just mentioned. As soon as you are bispecific, complex. And then if you want combinations, good luck. So today in oncology, for example, we did immunology because you had a monospecific, okay, try it, easy, boom, 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 works with the limitation you just said. Then we added a bispecific. It was complicated. I'm not even sure the value, right? And then we couldn't do onc yet, having a satisfactory model of a combination of, let's say, an ion and a chemical or an ADC. Good luck, yeah. Or, so I think we're still toying with these things to figure out, how to make them work. And when I say we, McKinsey is trying to sell their model, but, if you can only do monospecific, what's the future, right? So I don't know if that kind of answers your question. Okay.
I think it is time for lunch.
Yeah.
Thank you so much.